So now that we've established that it is very important to have repeated measurements in the baseline phase, you may be asking yourself, why? Why is that so important? So remember that single subject design is set up kind of like experimental design, but it's a single subject. And remember, the important thing about experimental designs is that you have a control group, and so you're able to use a control group to eliminate a lot of the threats to internal validity. Well, in single subject design, since you just have a subject, obviously you can't have a control. So this type of research is set up to where the single subject is its own control. Okay? So we're going to look at what this means. Basically, you have to start off assuming that you have this baseline pattern, right? And so you've taken at least 3 measurements, probably closer to 5 or 10, and you've more or less figured out what this subject, this client, or the supervisor would be like without an intervention. And you're going to assume that if you were to do nothing, the pattern would continue. So what that means is that that is basically the control. So you can now go and implement the intervention and compare it against the baseline. So now you have one subject being compared against its own control, which is that baseline phase. So this helps you distinguish, again, what happens with the intervention versus if you had no intervention. And in research speak, this basically means we use the baseline phase to discount threats to internal validity. Okay. Now, internal validity is something that you see keeps popping up and is hugely important because, again, internal validity means we need to show that this intervention that creates change, and we can actually say it's the intervention that did it and nothing else. So make sure that you're clear on some of these really fundamental concepts. Take your time over the next couple of slides. Pause and read through these if you need to. Reflect on these because a lot of this is really important research terminology, but it's important to understand this in research concepts because you're going to see this repeated. So for example, why is it that you can do this without a control group? Because those repeated measures rule out a lot of the threats. So for example, maturation. Sometimes you might be worried that if you were, for example, doing an intervention with somebody and you were trying to look at the impact of, say, an academic program on helping a child manage oppositional behavior in a classroom, well, maybe there's simply a maturation process that as that child gets older, those behaviors go down, and you might confuse your intervention with what's just normal development. Now, however, if you take repeated measures over days, weeks, months, whatever your time frame is, you might see that natural progression. So you might be able to then use some statistical analysis down the road to eliminate the part of your observations that are probably due to maturation and just leave out what is expected to be the impact of the intervention. Similarly, sometimes you might see that you see changes in a measure just because somebody's taken the test. So if you're doing a survey, somebody's taken that survey once or twice already, they start knowing how to respond. But if you do repeated measures, you'll see that change happen. And you can now account for that change, use statistics to eliminate those results when it comes to your actual intervention observations, and deal with it that way. Okay, so if you're still fuzzy about the threats to internal validity, this is the time to go back to Chapter 6 and look at experimental design and make sure that you familiarize yourself with that once again. Now, here's a really important thing when it comes to single subject design. So let's say you're able to use this repeated measure in the baseline phase to deal with a lot of the threats to internal validity. Does that mean your intervention works? Well, you still have to go back to this idea that there's an independent variable and there's a dependent variable, and you have to have an intervention, and then you have to see a change in something. So those rules still apply, even if you have a really good baseline phase that includes multiple observations. So if your dependent variable changes, if I do therapy and I see changes in somebody's depression level, does that mean my intervention worked? Well, in single subject design, we don't say it worked. We can never say we proved it. We can not even say that we have eliminated likely explanations. In single subject design, we now introduce a new concept of coincidence. And so really all you can say is you established a pattern of coincidence. That means everything else is probably unlikely. So keep that in mind. Nothing is proven, but it's such a coincidence that you can probably eliminate every other explanation. All right, so we've talked about baseline phase. Then we also have the experimental phase, which again, it should be understood now, that's where the intervention is introduced and we keep taking measures. So you see, we're taking multiple measures in the baseline and then we keep taking those measures in the experimental phase. How many you take just depends on the intervention itself, but you see you have to look at both. Both of these have to be looked at to look at how those changes are going to take place, all right? Here's just a quick and easy way for me to remember. In single subject design, it's all about the Benjamins. A is the baseline phase, B is the intervention phase. You'll always recognize the single subject design because the chart will look very simple and there will always be a clear distinction between baseline and intervention, usually drawn by a line in between the observations. In this one, for example, you see this is measuring disruptions. You see this worked a lot, obviously, in classrooms and educational settings. So you see the baseline stage included 1, 2, 3 observations that were all fairly high. And then the treatment stage and intervention stage included multiple observations that look like we have about 11 observations here. And you see a very distinctive pattern, which looks significantly lower than what the baseline phase looked like.